Hello, everyone. Let's start. The first topic is from our chief architect for the mobile, Oz from ONF. So his topic is for the run slicing. Let's welcome him.
Okay. Um, I literally finished the last slide 30 seconds ago. So this is just in time presentation. And actually, granted, because of all the organizations, I didn't have time to prepare this, but I'm glad that I left it to the last minute because this morning there was this panel on Edge Cloud. And there were certain assertions that I did not necessarily agree with. And that actually made me rethink this whole thing. So it is a completely rethought slide deck that you will see. So because those three people, the startups, all come from the cloud world, I thought, okay, we should start with comparing and contrasting cloud and telecommunication networks. So I'm going to start this with cloud computing as an analogy. And then that is going to take us to cellular network evolution towards network slicing. And then we're going to try to formally define what network slicing is and talk about what 3GPP is up to on network slicing, which to a large extent focuses on the core network. And then we'll talk about where we are with RAN and what we can do and how we can leverage the SD-RAN work that is ongoing both here at ORAN in standardization, how we can leverage that towards getting RAN become a part of this. And I will end, given the time, I'll end it with just one slide where I'll basically explicitly take this and merge it with Edge and how actually the network slicing is going to change how we look at the Edge. All right, so you know where we are with cloud computing, how we got here. So let's very, very quickly go over that. So when I was a PhD student in the lab where I was doing the work, we all had SunSpark servers. Some of you remember it. Some of you probably have never seen it. These were vertically integrated servers. Sun had their own processors, they had their own operating systems, they had their own applications, and you couldn't even think of having a third-party application to be taken in and installed. And they were very, very expensive devices. But what happened then was we went through this revolution with, which I could define as horizontal disaggregation, where we started having this commodity processors, and then operating systems and third-party applications. So this actually created a huge industry from a vertically integrated device to a horizontally disaggregated industry. We started having all these huge companies in all parts of this disaggregated compute platform. But next was the second one. So effectively, in short, this is sort of where we ended up, right? We had hardware disaggregated from software, and the software was further, and we had an operating system that sort of interfaces the applications with the hardware, abstracts everything so that application developers don't have to worry about how to actually access the different resources. So then the next phase was virtualization. And we went through this phase as well. There was, we added between the hardware and the operating system a hypervisor so that actually the limited resources could seem as many as we want it to be. Um, and we created an environment like this. Then this took us to cloud. So in a cloud architecture, we have a pool of hardware, and on it sits a large number of applications, and we have a cloud automation platform. And that cloud automation platform is also where the cloud operators monetize this. So in this, we have the underlying assumption that resources are seemingly infinite. And when we talk about resources, we can talk about first physical resources. They would be storage and compute and networking. But there are also other resources, right? We could talk about services resources. So there's a platform that we can actually compose and provide as a resource. Or there is software, actually, that we can compose and provide as a resource. And each of these resources, then I can elastically and scalably concatenate and monetize. So then, by definition, cloud computing is a style of computing where scalable and elastic IT-related capabilities are provided as a service using internet technologies. So here, elasticity, you all know this, is the ability to grow and shrink the resources dynamically as necessary. And scalability is the ability to increase workload size. Now that with this gentle introduction, let's actually pause and look at wireless networks. So today's networks, if the operator has not gone through virtualization, pre-virtualization, look something like this. I have base stations all around to provide coverage, and their traffic is aggregated towards a small number of centralized locations where on vertically integrated elements, we have core network. And even a smaller subset of those centralized locations are egresses that take us to the internet, where there is the public cloud and a lot of OTT applications we all use. So let's actually follow the same steps as cloud computing. So first, horizontal disaggregation. So let's start from the core. So we have actually, with release 14, gone through horizontal disaggregation. We have now at the core network, the user plane completely disaggregated from the control plane, and we have the applications such as IMS, internet access, etc., sitting on top. And I could potentially then apply it like this. Then if I virtualize on top of disaggregate, I end up with something like this, right? I have in these centralized locations, now they are starting to look more and more like the data centers that cloud operators have. I have the core network user plane, core network control plane, and my applications, again, in the horizontally disaggregated way. But we have not touched Duran. So let's try to do that. And again, using cloud computing paradigm, my resources could be physical, but at the same time, they could be services. So let's actually try to think of the resources we have in the RAN. First, I can disaggregate the software stack and virtualize it, right? So that virtualized unit I could basically just call it RAN connectivity VNF. I'm simplifying it. It's ideally a CU, but let's label it as the VNF that provides my cellular connectivity. So for me, this is actually a services resource. But it's very physically limited. So I can't really think in the cloud terms that we have seemingly infinite resources. There is physical limitations here. And then comes my sort of the compute storage equivalent, the physical resource in the RAN. And that is my spectrum. So it is actually quantized in the form of time frequency slots. But it is, again, very physically limited, and it is super expensive. It is probably the most expensive resource you can imagine. So in that case, the end-to-end, completely virtualized wireless network would look something like this. I would have a number of locations where I could host these virtualized components. Then the network resources, let's start with that, would be at these locations, I would have the storage, the compute, and the networking resources, just like the cloud paradigm. I would also have, as resources, the X-Hall capacity that interconnect these locations, as well as the front hall. And again, with physical resources, I would have the wireless time frequency resources so the equivalent of the cloud paradigm in a very distributed way. These are my physical resources. What are my services resources? Well, they are the core network user plane, core network control plane, my applications, and RAN connectivity service. And now in this environment, I have a bunch of different types of users. So just again, following on the cloud concept, these are my so-called tenants. They all want different parts of different resources from me. So in this, when we think of the wireless network this way, then network slicing is really a mobile networking platform using which elastic and scalable access and connectivity related capabilities are provided as a service to customers in a given geography using 3GPP standardized technologies. Then the elasticity and the scalability is somewhat similar. So if I want elasticity, I need the ability to grow or shrink networking resources, the spectrum, the compute, storage, X-Hall, dynamically as needed. And another thing to pay attention here, my customers are not necessarily just the end users anymore. They could be entire enterprises, or actually they could be the internal customers for an operator. Some business units who actually serve specific purposes are also customers for this. So then, how do I create the network slice? Well, I need some slice attributes. So this is a network, so that means I would have to ask from the network a specific latency, a specific throughput, reliability, mobility, locality, etc. And based on that, the operator would actually compose network, physical and service resources and create the service graphs and in a localized way deliver it. So this would be, again, using exactly the cloud example, how one would deliver it. This would be how you would monetize it. You would create it, and then you would make money off of it. So then we can take it to this. Network slicing effectively aims to transform a mobile network to a network cloud with distributed physical and services resources. So in that sense, network slicing is the paradigm with which operators can monetize their distributed network clouds. So let me very quickly pause here. Any questions or anyone disagree with me? Yes.
All right, I've got a question that I've been wondering about for a while. What is the difference between a network slice and a virtual private network?
Very good question. So a virtual private network, in that sense, is sort of you can almost see that as an overlay. Whereas in the network slicing case, I have all the way from physical resources and services resources composed to provide my end service to me. So the VPN that you're talking about doesn't really care what the underlying connectivity solution is. It's agnostic to it. So it is an overlay of the network slice that I'm talking about.
Thank you. So this is not so much a question, more of a reiteration to make sure I understand. What you're saying is that a telco cloud would have, whatever compute resources it is that there are out there, and on demand it would spin up, a vRAN and a virtual EPC or virtual IMS to serve the needs, allocate spectrum dynamically, and service that user. If that's the case, how does the actual radio pop up?
Okay, so effectively, again, going to a cloud solution. What you say sometimes happens in cloud, but there are times, a lot of times, where you will have platforms actually pre-configured, and whenever you request it, you will just get it, right? So the same will probably apply in the network cloud sense. So you're asking about radio. Of course, those resources are there all the time. The spectrum is available, right? But in a limited way. So the resources are not infinite anymore. So that lack of infinite capability brings in a different set of challenges that cloud companies don't necessarily have. That actually makes workload placement, scheduling, prioritization such an important and essential component of this, so much more important than the traditional cloud paradigm.
Isn't it already we are slicing the spectrum on time and frequency domains? We are also slicing the radio on the beams that we transmit.
So hold on to that thought. I will get more into detail onto RAN slicing, and maybe that will answer your question. All right? So let me continue. So at least now you understand that I'm trying to look at the wireless network from a completely cloud perspective. So I'm just, and in that sense, I have resources that are physical. I have resources that are service-based, and it is just a matter of creating the platform that automates how I actually get the infrastructure resources and the services resources to compose whatever I want or whatever my tenants want. So within 3GPP, starting with release 15, there is network slicing. And the network slicing solution is confined to core networks. So let's first start with some definitions which will make sense for everyone. So according to the network slicing standard, a network function is a 3GPP adapted or defined processing function in a network. So it's a VNF that is 3GPP defined. A network slice is a logical network that provides specific network capabilities and network characteristics. This is how they define it. And a network slice instance is a set of network function instances and the required resources, compute, storage, networking resources, which form a deployed network slice. All right? So with that, actually, now you can think of these use cases, and in the 3GPP lingo, these are communication services. And you will have a number of core networks and a number of access networks. Then the network slice actually is something like this. So you can have, for a given communication service, you can define the slice to be composing multiple core network instances and multiple access network. Or you could have a one-to-one. So that 3GPP allows you to have, for a given service, a configurable number of core network instances and a configurable number of access networks. And specifically, how it works is something like this. In the 5G domain, you have a service-based core network architecture. And in this architecture, some of the network functions are going to be device-specific. And these would be the access and mobility function, the network slice selection function, and the network repository function. But session management, user plane functions could be slice-specific. And as a handset or as a mobile, you can have up to 8 parallel slices. Okay? So that means you could have up to 8 UPFs serving you at the same time. So the way you actually get that is, by the way, each service is a priori composed by the operator, and each one has a description. So it is called a single network slice service identifier. Thank you. So then, just like the old QCIs, there are these service slice terminologies. And for example, an ID of SSD1 corresponds to broadband, and SS2 corresponds to low latency, and 3 corresponds to massive IoT. But an operator can have multiple slices for each of these use cases. So that is defined by the slice differentiator. So an identifier has both. So then, a slice is triggered by the handset. So upon registration, your handset will be sending a request. And that request will have up to 8 slices in it. And these will be just slice descriptions. So if, for example, we're talking AT&T, they could have maybe up to 10 different specific slices for broadband. In that case, these slice descriptions would be oh, I want this slice, that means I want broadband within this category. Okay? So once that, and that is going to be received by the AMF. Once AMF receives this, it is going to ask the slice selection function, which slice instance should I actually have for the first one? And by the way, that handset needs to connect to PLMN-X. But before doing that, there's one thing that I did not show here, which is before actually accessing NSSF, it needs to make sure that the slices requested by the handset are okay to be provisioned, and that's based on the subscription SLA. So that needs to be checked first. So I'm assuming it's all okay. Then the NSSF answers exactly which slice instance that corresponds to. Then the next thing AMF does is it asks the repository function, I want to get NS network slice instance 1. Where are they? Where are those components? And the IP addresses will come, then the composition for the end-to-end connectivity will take place. So what about Duran? So you probably have seen this early on, this slide. Okay. So here, in our RAN stack, we have two really distinct components where we conduct radio resource management control. And the rest is all about packet and signal processing of data and control messages. So when we can disaggregate this, but in addition to that, we can do NSDN-based control. So ORAN is working towards standardizing the interface between the controller and these components. And you don't need disaggregation. You could potentially, if there's a compliant all-in-one base station, you could do that on this one as well. But here, we call this the near real time, right? But, and this is logically centralized, and it sits at the edge. But there's this component here as well. So for my purposes, I'd like to call this real time. So the RAN controller then will look like something like this. I'll have the near real-time controller that has a bunch of RRM control applications, and the real-time control, which is the scheduler, will have probably a number of schedulers on it, sitting on it. And as far as the network state is concerned, these will the real-time control will need instantaneous QCI values, whereas these would probably need time-averaged QCI values. And the device configuration, session information, etc., will also need to be there. So in this setup, let's zero in on the scheduler. The scheduler does a number of things. Number one, it decides on which users to serve at a given time. Number two, it says it decides on how much of the spectrum to give to each of the scheduled user. And number three, it basically says, oh, I'm allocating this many resources to this user, but it is exactly these ones I need to allocate. So it does the actual mapping. All right? So for slicing of the RAN, what we need to do is we need to disaggregate the scheduling operation and virtualize my resources, just like I did with the processor in the cloud mapping. So what happens then is my scheduler actually does this mapping to my virtual resources. And separately, I do a virtual to physical mapping in using another software. All right? So once I do that, once I disaggregate these two, then I could do things like this. I could say, oh, for these users, I'm going to be using this scheduler. And this scheduler is going to actually have access to only this much of my virtual resources. And this scheduler will have access to this much. And then collectively, I'll do a virtual to resource block, physical resource block mapping. So if this is the virtual mapping, again, the physical mapping will look like something like this. And I could do this on a TTI level. And the elasticity of this could be a TTI level as well. So then, the configuration of these slices need to come from the near real-time controller. So I need actually a slicing application that sits on the RIC that allows me to configure this in near real time. In addition to that, I also need the capability to have multiple options of these RRM functions so that I can do the stitching. I could just say, oh, for this slice, I also want to use this handover algorithm with this interference management algorithm. And that effectively gives you a virtual base station, really, inside a hardware. And that is your RAN slice.
So that's a structure of a cloud run?
No, this is a sliceable base station. So Cloud RAN basically just is disaggregation.
So that's running in a base station, or I'm a bit puzzled about how do you implement that in real life. Which part of this? I'm a bit puzzled.
So don't forget, we're talking about the scheduler. So if you go back, the scheduler is right here. So in the Cloud RAN structure, the scheduler is inside the DU. So this is what I am configuring right now.
Yeah, but currently in today's world, either the scheduler is at the MAC layer of the monolithic base station, and now you want to take it out to run it on a server. So this is a concept known as Cloud RAN.
Yes.
What am I missing here?
That's true, but I am also, in addition to that, turning that into a programmable entity. And I'm also saying, as long as you have access to that stack, you can keep it monolithic and still make it programmable. Yeah. Let's take it offline. Okay, let me continue. Yeah. All right. So I will actually go to my last slide. So this is actually then tying this with the edge. Now we are starting to define the mobile network as the distributed network cloud, and we have a public cloud. So effectively, edge really is where public cloud meets the network cloud, would be my final description. So if I have a handset, and if that handset wants to reach an OTT application, this is the network, right? I have a mobile network that includes the RAN and the core network with an egress to the internet. And from that internet, you reach the public cloud, and you reach the OTT. Now, independent of the telco ambitions, public cloud companies want their own edge. So this has started by disaggregation of the OTT applications into microservices. So some of those microservices, they assert that it is better to get closer to the end user. So you can push it to the enterprise locations, for example. But if your egress has not changed, this won't necessarily buy you all that much. And actually, it could even make things worse. And in parallel, operators are going through the transformation of turning their network into network clouds. So in that paradigm, we have a mobile access edge that could be a central office, and there are central locations. And on this, there are multiple instances of the user plane functions and control plane functions of the core network. And there's also this user plane function. You can also imagine there's the RAN component there as well. So in this setup, there could be a mobile edge egress here as well. So then, if there is an internet connection here, then actually I could potentially even host this here, and that would be the optimal solution for me as far as the end user is concerned. But even if this doesn't happen because the public cloud and the telcos can't agree on co-hosting these, the alternative would be to realize this. Now we live in a network slice era. So the operators will programmatically create network slices. There could be one slice like this, where the user plane function is sitting here. So that means for this traffic, the egress is here. And the other network slice would be like this. The user plane is here, and the control plane is in the central cloud. That means the egress is here. So then it is to the benefit of the OTT to become a tenant to the telco cloud, and as a tenant, ask for network slice instance number 2. So effectively, the two clouds need to talk. So there needs to be a means of the public cloud asking for intent based on the type of services. And what would be even more ideal is if there was an end-to-end management that actually oversaw the two.
Quick question. So this is effectively local breakup for the mobile operators?
Yes.
And how is this different from, say, in the LTE days when a subscriber would be looked up in their HSS, given back to QCI?
The slicing, aside from the local breakout, how is it different from how the LTE handled it?
So this is going to be a lot more dynamic, right? I mean, effectively, unlike the LTE days, now you could use a lot of the cloud principles. So if there's an edge and if there's no need for a user plane function to sit there, then no operator will have to place something and have it sit idle. You could actually instantiate it on demand. And you could even migrate these workloads based on the needs.
I have one other short question. You mentioned near real-time and real-time, where there was virtual resource block mapping to physical resource blocks. Is the reason this is called near real-time because the resource blocks may interchange on the other side?
So the reason, good question. The reason that it is near real time is normally in the wireless channel, things change really rapidly, okay? But there are certain radio resource management operations that don't need to follow those changes as rapidly as they occur. Just a filtered version is sufficient for them. And that's why, again, if it is, imagine millions of users, if those changes are very rapid, and if you actually send all of that information up, that's a huge bandwidth. And if it is not necessary, then you wouldn't want to do that.
So if there's an operator, they only have the mobile network cloud, but they rented their real estate or those used to be their buildings to the public cloud providers. What's the boundary between? I know there may be some regulatory issues. They can't really talk like that. How do you solve that problem?
Can you repeat your question?
Yeah. So not every, like most of like there were two kinds of operators. Some operators they have end-to-end is all their cloud, and some operators they rent their old buildings to some public cloud providers, and it's already rented out like a landlord, right? And they only own their own mobile network cloud. There is a boundary, like I'm the landlord, you're the tenant. Can I still talk to the public cloud my tenant is running? Yeah.
So probably the answer to your question is going to be governed by the national laws. So depending on which country you're talking about, it is going to be different. So in the US, to my knowledge, running all aspects of EPC from the public cloud will not be allowed. There are certain aspects that are subscriber control basis that a telco needs to do it on-prem.
For private LTE, they do allow it. AWS has a full EPC core, and all what they tell you is just put up an LTE CBRS.
But that's different. Again, this is I'm talking about a license frequency owner.
Yeah, I guess we have a lot of questions. We can talk, ask
Yes.
out offline. This session is run out of time.
Thank you.